Alright, so if you followed me for a little while, you'll know that I like to have everything turn on with my computer. So I got a microphone preamp that turns on with the computer. I got amplifiers for speakers or headphones, got to turn on with the computer. Monitors, got to turn on with the computer because they're all connected to the computer. So when I turn the computer on, everything should turn on with it. I don't want to, every time I turn my computer on, play Microsoft Flight Simulator. It's a little bit tedious after a while. So there we have it. A single relay comes on underneath my power strip, and the power strip comes on with the computer. All of these devices turn on, except this one, because the people at Massdrop thought it would be an excellent idea to make a digital power supply with no professional 12-volt trigger built into it. What a fantastic idea, Massdrop. What a fantastic idea. Now, what we're going to do, I've taken this apart off camera before. We're going to make this thing turn on automatically with the computer. But the problem is, how are we going to do that without adding a computer input? That's a problem, because I don't want to add yet another input. I already have a power strip that automatically turns on. If you want me to make a video about how to make one of those, I can do that later, but you can buy them pretty much. Most UPS have them too. Essentially, I don't want to add any more inputs to this. So what I've thought of is, what if we just have the thing constantly turn on as soon as it gets power, like a mode where as soon as you give this thing power, it's going to try to turn on. So I took it apart, I looked inside of it, and sure enough, it's this convoluted amount of power switching and whatnot, and I didn't want to. I was starting to draw out the circuits, and then I realized how many components there were in it and how many I'd have to look up and then figure out how it works, and I was just, can't be bothered. So what I'm going to do is I'm basically going to make a circuit that just, as soon as it gets 24 volts, be on a delay, trigger a relay that's going to pretend to push a button. When the white LED comes on, it'll kill the circuit, basically simulating the button press, and then it'll all be off. There's probably a more elegant way to do it, but basically what that'll do is when you have this thing plugged in, it'll constantly try to turn itself off. Sort of like that little box with the cat hand that you push the button and then it flicks the switch back off, and that's all it does. You push it and then it turns itself back off. So if you turn this device off, it's going to turn itself right back on again. That's what it's going to do. So let's make it do that. Of course, if you were smart, you would add your own switch at the back to disable this functionality. I don't care. I'm going to have it constantly on. So, yeah. Let's get to it. First off, though, I want to prototype this circuit. So, I'm going to go ahead, build that off camera, and then we'll see if that works. And if that works, then we'll move forward to actually soldering together the board and putting it in there. And I'll show you how that works. Don't worry, I have this schematic drawn up somewhere in here. There. I'll post that if you really care about it later on, if you care. Anyways, let's get to it. Alright, so here's the basic timer circuit. We got the 24 volts from the original power supply on the THX. Just plugged in dangerously right here, and you just wire that up to the regulator. 1, 2, 3, 4, 5, 6, 7. Give or take. I counted a little fast because I was a little behind. But yeah, about 6 seconds, 6 to 7 seconds, and that LED comes on. And then we can pretend that at that point, the white LED would have come on, breaking this circuit. So another relay back here would have went and turned it off, and the whole thing's dead. And so that white LED powers a relay, which shouldn't be too much current draw. I think that'll be okay for the amplifier. And then as soon as you turn the system back off, so if you push the power button again, then the white LED goes off, thus shorting this back together, and after about 6 seconds, the machine turns back on. Welcome back. So, my light's fallen off in the back. I need to find a better way to secure my lights. The epoxy I used to use is starting to not work, so I'm thinking of 3D printing a mount. Anyways, let's get back on the subject. What I'm doing now is I've finished making the circuit itself. That's what we're doing right now. So we're taking this apart. To take this apart, this is why I put this back here. I figured I might as well show you. So it's all just Torx screws. Which Torx is it? I'm betting it's a 15. It's a 10. It's a Torx 10. And you just take out 1, 2, 3, 4, 5, 6, 7, 8, 9. All 9 screws in the back. You'll see very long rods come apart here. Let's do a little fast forward actually. Ready, there's your screws out. This just comes right off. Did not put it back on. Just kidding, it fell right off as soon as I took the screws out. And on the bottom, of course, they put a tiny little screw that I forgot to mention. Same Torx 10, just took that one out. No hidden screws. No hidden screws. You don't need to worry about taking the feet off, which is really nice of them. Something I thought they might do initially when I first opened this. Nope. Which is really nice. Now it just slides out. So we just take it like this. No need to unbolt the potentiometer at the front. Just take it, and out comes the board. Slides out of that tray. And there's the long standoffs I was talking about. Bit of an odd design. I don't know why they did that. Let's put all this away. So I thought I might as well give a progress update right here. So I put together the circuit here, as I said. And as you know, I was originally going to use the LED as a means to turn the circuit off. So it would be, this is constantly on, so it comes power, waits 7 seconds, shorts these together as if I'm pushing the button, and then when the button's pushed, then the LED at the front here will cause this circuit to die. So it'll give up another relay, power another relay to take this out of the normally closed position to the open position, killing this circuit. And the idea behind this was not only to have a pulse so we can get control back into this, but also to save power. Well, as you probably already have guessed, that's dumb, because that's not saving any sort of power. You're going to be consuming the amount of power that the coil takes to power that relay. So I actually put this together off camera with a separate one, with the LED, and it was using about 30 milliamps, so that's a waste of power. You might as well just have this running constantly as a shorted circuit. So that's what I've done, just as a demonstration here to show that the idea at least works. So if I'm going to plug this in, the device, zoom out. If I plug this in, the device will wait 7 seconds. No power, no hands. And it's on. So, have to wait 7 seconds the device turns on, but I can't turn it back off because we're just shorted here, which is kind of a problem. So, as I said, originally we wanted this to turn this back off so you could turn it back off and it would keep turning itself back on. Well, that's kind of dumb too, so I thought, in order to save energy, what we'll do is we'll eliminate that whole relay idea, and we'll just have it fire once at the beginning, as soon as it gets power, because that's all I really need, right? My power strip gives power to this, and it turns itself on, and I can choose whether to turn it on and off all day long until I turn my computer off, which is a way better design in my opinion. So what I'm going to do here is I want a delay on a monostable circuit. So there are a few designs, and I looked a few of them up to get an idea, that people have come up with that allow you to do a delay and then a pulse and then off. But they have some weird caveats, like if you first plug it in, there's a weird initial pulse and stuff like that. And I just didn't like it too much. So what I'm going to do instead, and it's going to sound stupid, is we're going to use two 555s to create a delay and then a monostable circuit, or one shot. And so this will be the 7-second delay, and then we'll have a separate one that does the one shot. And I've already designed the one shot here. Instead of having the typical button, I've just put a capacitor in instead, so as soon as you power it, you have a certain amount of time. Sorry, just moving this over so you can see the amp meter. And then so on and so forth. So right now it's on, it's been on. I'm only drawing about 3 milliamps. So that's the idle state, so to speak. So if we disconnect it, we wait a couple of seconds. We can pretend that 7 seconds has passed after. This is pretending that 7 seconds have passed, and it is now powered. Boom, we get a pulse, and it's off. So there we go. And now we're only drawing about 3 milliamps. In the end, I might end up using CMOS 7555s, because those use even less power, but 3 milliamps isn't too bad. So, might change them out in the end of the design, we'll see. That's what we're going to do though. We're going to move this off a breadboard again onto another circuit, and so this will be powered by a delay. If someone in the comments, I'm sure someone knows, you can probably power all of it off of one single 555, delay, pulse, and then nothing. But I'm going to play it safe and do two separate ones. Okay, so here's the final two circuits. We've got the 7-second one, sends its output to the pulse sends it back to here, triggering the relay for a little bit, and then turning it off. And we idle at about 7 milliamps, so let me plug it in. And we'll watch that right there. So you gotta wait a second because the 24-volt transformer takes a bit. Okay, now we're idling. We're gonna count up. There's our relay on, there's our relay off, and then we're going to idle it around 7 or 8 milliamps. So, again, I'm thinking my final design, when I put up the bill of materials and all that you need to do this, probably will recommend the CMOS versions, and I'll probably make a follow-up video after this showing that, but either way, now I'm just going to 3D print the case, which is just going to be a little tray, and then we'll be able to screw it in onto the board. Okay, see you in a second. This black PCB is pretty reflective, so it's hard to see things too well, but first thing that we got to do here is we got to solder up our negative to this diode here. Or is it a fuse? Let's see if it's a diode or a fuse. Uh-oh, you got me on a roll here. 100K. It's definitely a diode. Yep. So we're going to solder it on this end of the diode, so the end closest to the outer of the shell, and that's our negative, right? Only because there's no terminal that we can solder onto on the negative, it's underside the board, and rather than running through the holes and all that, we're just going to solder right there. And then for a positive, we're just going to solder on the back side of the plug. So right there, that's where a positive will go, which you can see I've already done before in testing. So let's do that real quick. Ideally I should move this in place or something, stop moving around. Let's just put it in place and then we'll add more in a sec. 1 second there. Where is it? There it is. Oof. What a day and a half it is. Everyone's gonna get mad at that. Oh, there's still flux burning. Who cares? Should be good if the flux is still burning, right? Alright, next one on the back side here. See if I can a little bit and get a hold of it better. Put this back. Just so that I can solder it on a little nicer than you just saw me do with the negative. Come on now. Sometimes it's hard to get these things just right. Oh, jeez. And voila. Not bad. I think I couldn't actually see what I was doing, I'll be honest. Yeah, that's okay. Not too bad. Could be worse, could be better. Maybe I should have soldered it on the other way. Well, we'll fix that later if I want. Now we need to solder our green wires, so we need to take the green wires up and around back. Underneath, so I fished them through this tiny little hole typically on the side here. I don't know if you can see it too well. There's a tiny little hole next to this, so we're going to fish those through like so. Oop. Skidoop. Now, when I was first doing this, I spent literally 3 hours trying to figure out why, not 3 hours, but I spent a good couple of minutes trying to figure out why the relay wasn't firing when I put in the second circuit, because I only tested it with an LED, which is a side story here. And the reason was I wasn't wiring it up to the right leads on the relay. Somehow. I don't even know how. But I started going, oh my lord, I'll need a transistor, because it's not putting out enough power, now that I'm using the second circuit. I knew it was a dumb idea, yada yada yada, etc, etc. So I kind of want it like this, if I can get it to go like that. I need all of this wire, don't I? Thought I could shorten it a bit, but looks like I might need all of it. Okay, let's flip it over to the other side. So let it dangle a bit here, that's fine. And we're going to solder it right up to, zoom in a bit more, those two leads right there. Kind of awful to solder to, but we'll do it anyways. Will this guy help me out? Kind of makes me want to remove it and redo it. Look at how gross that is. It's like it's got contaminants and there's something in there. Whatever. It's also, oh, it's a cool solder joint, trust me. I've done this 8 times now, and it's always the same contaminant. I should solder suck it and go again. Should I do that? Solder suck it and do it again. Aha. Aha. Proving you wrong, you comments. Look at that. That one is way shinier than the other one. You know why? It's not lead-free solder. I'm not going to fix that. Should I fix that one? It does bother me a little bit. Okay, so here it is all finished. I put a little case on it. Just put 2 little tacks of glue because I'm probably going to take it off. A little bit of glue along the side to hold the wire. I was originally going to do zip ties on here, but then I realized that this is actually a trough, so the wires wouldn't fit. So unfortunately this strange standoff has to stay, and I just glued it down with a little hot glue just to keep it nice and organized. Underside, I even went to the time, just because I know it'll bother someone, I went to the time to resolder those like I said I would. So you can see it's nice and shiny because I took off all the lead free and put some good fresh stuff. It's all nice and organized, ready to go. So now it's just a matter of putting it back together, so let's time lapse that. So time for the big reveal. Well, we know it already works, but let's turn my computer on now that everything's back the way it was. See, my power strip downstairs comes on. Microphones are on, monitors are on. Now we wait for this circuit to activate. There we go, the circuit is activated. I didn't need to push the button or anything. And that's that. But the thing to note, as I said in the beginning, this circuit relies on the fact that I already have a power strip that is managed by the computer. So the power strip downstairs already cuts AC or delivers AC depending on the state of the computer. So what I'm basically saying is, if you don't already have that, this design will not work for you, but it can easily be modified. So rather than, if you just have this unit and you don't have these downstairs, you know, some sort of AC that cuts on and off with the computer, then you can use you can modify the circuit so that instead of using just the mains 24 volts, you can use a XOR gate with a 5 volts from a USB. So you would take USB power from your computer, put a USB port on the back of this unit, feed the USB into the XOR gate, and then also use the 24 volts from this, either the relay that tells whether the headphones to be on or off, or you could use the LED. I don't think that's 5 volts though, that's only 3 and 3.3. So use the relay here, step it down to 5, and then use that in a XOR gate to determine whether or not to activate the circuit I just used rather than the mains 24. So how that'll work is, if both are off, we're not in a XOR state obviously. It'll be powered by the mains still, the XOR gate itself. If the computer comes on, so that's 5 volts, okay, the XOR gate will activate, that activates my circuit. So that tells it to turn on the unit, okay? The unit will come on and activate its own relays, which will then also trigger go into the XOR gate. Now we're no longer in an XOR position, so we're going to turn off my circuit. Now it is ready to be reactivated. You're going to use the device, etc., etc. You turn off the computer, so now the 5 volts is gone. Sorry, I'm going to give you the middle finger there. The 5 volts is gone. Now that the 5 volts is gone, the unit is now in a XOR state again. So we can basically turn off this unit circuit again. So the circuit will become active, and then the button will be pressed, and thus turning it off and turning us off into a 0 position again. And now the unit is turned off with the computer, and the cycle can repeat endlessly. So I will draw these diagrams up. I will draw the diagram up for if you are going to use this. If you already have like a UPS that's managed by your computer, or some other sort of power strip that's managed by your computer like me, I'll draw that circuit up. I'll also draw up the circuit that assumes that you don't have something like that, and you just want this unit and this unit alone to turn on with your computer. I'll draw up something that includes a USB port and the XOR gate to turn on and off. Okay, hope you found that somewhat interesting. It's a little bit complex at the end there, and yeah, see you next time.